Next, we will look into the one more example. This time it's university crime. So let's see what's there. So at a university in Western Pennsylvania, there were 5 burglaries reported in 2003, 16 in 2004, and 32 in 2005. If a researcher wishes to select random 2 burglaries to further investigate, find the probability that both will have occurred in 2004. Okay, just let me understand the question. If a researcher wishes to select at random 2 burglaries, okay, he randomly will select 2 burglaries to further investigate. Then find the probability that both will have occurred. Okay. Both will have occurred in 2004 only. Okay. Your total sample space would be 5 plus 16 plus 32, but he was interested in 2004 only. So then, obviously, one is dependent. Okay, yeah. So now these are obviously dependent events because both events happened in 2004. In 2004, maybe it might have happened one after that. So obviously C1 is dependent on C2. So that's the reason probability of C1 and C2 is equal to probability of C1 multiplied by probability of C2 given that C1 has occurred, because you want to find the probability that both will have occurred in 2004. We are worried about 2 events in 2004 only. Then obviously they have to occur, and that too they are dependent. These are not completely a different independent event, like independent events like flipping a coin and then rolling a flipping a coin and rolling a die. Those are completely independent events, but here these are absolutely dependent. They happened in 2004 only. It's not that in 2003 and 2005. They happened in 2004. They want it from 2004. That means, so one instant had happened. So once you have calculated the probability of that event, then the second event to happen. So that event will be dependent on this. So that is the reason what we do is first we'll calculate the probability of happening any single event. Then once that event is done, now second event to happen, then we have to reduce the sample space as well as the number of crimes also, because one event has already been calculated. Now you have to deduct it from that, because here what we are telling probability of crime 2 given that crime 1 has happened, then only you'll get 2. So 16, obviously 16 initial to get the first probability, first crime, to get into the first crime. So 16 divided by total 5 plus 6. Okay, 5 plus 32 plus 16, it's 38. 48 plus 5, 53. Okay, so 16 divided by 53, absolutely fine. So one event happened. Now at the same time another event to happen. That's the question, how it is possible. And if they are completely independent events, then there is no issue at all. If they are completely independent. You can do both at a time, like this: flip a coin, roll a dice. But these are not completely independent. They happened in 2004 crimes. So now what I can do is both. If both want to happen, then obviously I have to after the calculating one event, I have to reduce the other one. So that's what I did here. So from 16, my 16 become 15 because one event has been done. This event has been done. That's what I'm saying. This event has been done. When it is done, you just keep it aside. Now 15 and overall sample size also will be reduced because it happens given that the probability of C1. Given that the probability, given that C1 has occurred. So that's the reason 15 divided by 52. That's it. It's 60 divided by 6, 8, and 9. Okay.